Alright, today's lesson is lesson 11.3. We're going to talk about dividing polynomials. This is a little bit different than if you remember from lesson 11.2. We talked about multiplying and dividing polynomial expressions where they were set up for you with two rational expressions side by side, and you were multiplying or dividing. So with that, you just flipped the second one and multiplied it. But we're going to do something a little bit different today. The first one is an example of dividing a polynomial by a monomial, which you've actually done before, but it just shows you the difference. So this is dividing polynomials. It's lesson 11.3. And I'm going to walk you through the first example, and then we'll write a little bit about it. Example 1 says to divide 8x cubed plus 4x squared, subtracting 12x by 2x squared. So in this case, you just have a polynomial, it's not a fraction, and then divided by a monomial. All you're going to do when you have that is, and you did this in chapter 7, is you're just dividing each term. You're simplifying each term individually by 2x squared. So you're going to look at this term, the second term, and the third term each, and rewrite them all as a fraction being divided by 2x squared. So I have my original 8x cubed plus 4x squared subtracting 12x. And then I'm going to divide each of those individually by 2x squared. And then you're just going to simplify each monomial fraction here as much as you can. So from here, you just want to look at 2 goes into 8 4 times. You have 3 x's here, 2 x's here, so you're going to have 1 x left at the top. Bring down your addition sign, then you're looking at the next term. 2 simplifies to 1 and 4 simplifies to 2. We have x squared, so they just become a 1, and they're gone. Bring down my subtraction sign. 2 goes into 12 6 times, and then I'm actually going to have an x left over underneath in a fraction, because there was 1 in the numerator and then 2 in the denominator. Now this is simplified as much as it can be. It's not in standard form in the sense that we have an x right here. Sometimes you might have to actually go look for something that's in a different order. But for this example, that's fine for your answer. There's no like terms to combine there. So that's your answer. Some of you might be wondering why you can't combine these two. The reason is because it's a 1 over x. You need to remember, or 6 over x. So this x is actually in your denominator. This is in your numerator. So it would be difficult to combine them unless you wanted to try to find common denominators and do that whole thing, which you don't want to do here because it's not an equation, it's an expression. So when you're dividing a polynomial by a monomial, you're just going to divide each term by the monomial. So they're going to be fractions, and then you're going to simplify them. Next, we're going to talk about dividing a polynomial by another polynomial, actually by a binomial. In this case, this is something where it can't be divided like you were dividing in lesson 11-2 because there isn't anything you can simplify and cancel. So you'll see what I mean when we start it. Example 2. Divide 2y squared plus 3y, subtracting 40, by y plus 5. So if I was to actually write this as a fraction, I'd have to try to factor right here. And what I would most likely find in this case is that there is not going to be a factor of y plus 5 that's going to allow it to simplify like you were able to do the other day. So when you see them set up like this, you don't want to take it and put it over y plus 5 and then try to simplify and factor. What you want to do is you're going to set up basically long division. You're going to be doing a long division but with a binomial instead of a monomial. So you're dividing it by y plus 5. So y plus 5 is divided into 2y squared plus 3y subtracting 40. Okay, you're going to follow the rules exactly like you would follow rules of long division. So you just have to kind of stop and think about it. And as long as you treat it like you would treat long division, this will work out for you. Biggest thing is you're looking at this first term right here, this y. You just want to focus on that. And you want to ask yourself, okay, how many times would y go into 2y squared? And you should have figured out it goes into it 2y times. Just like long division, you wouldn't put the 2y over what you just divided into, you'd move over one space. But instead of moving over one digit, you're going to move over one term. So y goes into 2y squared 2y times. Notice my 2y lines up with my 3y here. And that should happen right there. Okay, so now you're just going to multiply exactly like you would in long division to get what you're going to have in your row right here. Only difference is instead of multiplying once, you're multiplying twice. So you multiply 2y squared, or 2y times y, and you get 2y squared, and then you multiply 2y times 5. I'll go ahead and put that in green so you see. 2y times 5, and it's going to go right there. And you get plus 10y. Just like long division, you're going to do exactly the same thing. Draw your bar, and you're subtracting. You need to remember, though, that you are subtracting everything. So you're subtracting this term, and then you're subtracting this term and this term. You have to subtract both terms. You can't add here. If this was already a negative, then it would become positive. But whatever you're doing, you're thinking subtraction there. Notice your first term canceled now. 2y squared minus 2y squared is 0. Just like long division. That's your whole purpose in long division, is to get that first number there to cancel. It did, so this becomes a 0, and then I subtract 3y, subtracting 10y, and I get a negative 7y. Okay, again, following the exact same rules of long division, next thing I would do is bring down negative 40. So this is applying something you've been doing for a very long time just to a binomial, to two terms. But you're going to follow the exact same rules. Okay, so now you're going to follow the same rule again. Divide y into a negative 7y. And you should have negative 7. And now I'm going to do the exact same thing. I'm not going to draw arrows here because I don't want to get you confused. But you're doing the same thing. Multiply negative 7 times the first term, multiply negative 7 times the second term. So negative 7 times y is a negative 7y. Don't worry about this right now. You'll see what happens when we go to subtract. Negative 7 times positive 5 is a negative 35. Now don't forget, you're subtracting these. So negative negative actually becomes positive, and those cancel. Negative negative here becomes positive, so you have a negative 40 plus 35, which is negative 5. Now, does y go into negative 5? You should have said no, it doesn't, and the reason is this is your remainder, just like we used to have a long time ago in long division. So your final answer to this is 2y minus 7, and then just like you've done in the past with remainders, minus 5 over y plus 5. And you're done. So over here, the best thing I can tell you to do, and you might just have to watch this a few times, is follow long division rules and polynomial rules. And what I mean by polynomial rules is something like when you're multiplying binomials, you multiply to both. When you're subtracting a binomial, you distribute that negative to both. All those rules that you already know. So the really nice thing about this is that it looks very, very difficult, but in reality, it's doing something you've been doing for a long time and just applying it with all these rules you've been learning and you already know. Alright, now we're going to try an example that has, if you noticed in the very first example I did right now, well, example 2, it was in standard form and you had an x cubed, x squared, x, and then a number kind of thing. So I'm going to show you what happens when it doesn't follow that order. It's pretty easy in terms of setting it up, you just have to remember the rule. So I'm not going to write anything on the left, I'm just going to go ahead and just show you the example and write a couple things about it. Dividing polynomials with 0 coefficients. That kind of gives you a hint as to what you're going to have to do right there. So the example is divide 4x cubed plus 5x subtracting 3 by 2x subtracting 1. Okay, so if you notice, we have x cubed and then we have x, but there's no x squared. And if you think about that last example we had, as we were multiplying this back out, we were getting matching terms lining up. And so we're going to need that same thing to happen here. And in order for that to happen, we're going to need an x squared. Well, the rule you've known forever is 0 times anything is 0. So what you're going to do is you're going to use a 0 coefficient to hold that place value when you write this problem out to divide it. So just make a little note to yourself here. I'm missing x squared. So fill in with 0x squared. And the reason we're using a 0 is because now 0 times whatever that would just be 0 anyway. So we haven't changed this expression at all. We're just kind of adding something into it to hold place value, but it really doesn't change that expression. It'd be like adding zeros after your decimal. It doesn't really change it. They're just there. So now I'm going to rewrite it. 4x cubed plus 0x squared plus 5x minus 3 by 2x minus 1. And that's the problem I'm actually going to use for my division. So again, right here, I want you to just follow the rules you know about polynomials, follow the rules you know about long division. So 2x minus 1 divided into 4x cubed plus 0x squared plus 5x subtracting 3. What I like to do is I like to just kind of put like a rectangle or something around that first term so I remind myself that's the term I'm looking at to divide into. This I'm still going to multiply to as I'm going through, but I'm really not worried about if 1 goes into any of these or -1. I'm worried about the first term, the one with the x. Okay, so how many times does 2x go into 4x cubed? You should have had 2x squared. Notice there's your x squared it's going to line up with, so that's why you needed that there. It goes into it 2x squared times. Now you're just going to distribute this to each term. So 2x squared times 2x is 4x cubed. 2x squared times a -1 is a -2x squared. Don't forget you're subtracting each set of terms. So now that you subtract, this is a 0. This actually becomes negative becomes positive 2x squared. Be really careful with your signs there. You don't want to mess this up just because of that. Okay, now, same rules as long division. How many times does 2x go into 2x squared? You should have a positive x or a 1x. Notice again, x and x are lining up there. If those weren't lining up, I know I made a mistake. So I'm going to go back and start trying to look at what happened. I might have missed putting a 0 in for something. Or maybe something happened here when I originally lined it up. Maybe when I multiplied here, I multiplied wrong. Or when I subtracted wrong. Different things that can happen. So if you don't see these line up, you know you made a mistake. Okay, now I'm going to distribute x. X times 2x is 2x squared. And if these don't cancel each time when you subtract, you know you made a mistake also. X times a -1 is a -1x. And I forgot to bring this down, but that's okay. I can bring it down now. There we go. Okay. So now I have to remember I'm going to subtract 2x squared. Subtracting 2x squared is 0, which is what I wanted. Positive 5x, this becomes plus 1x, becomes 6x. And now this time I'm not going to forget to bring down my -3 at the beginning. And again, I'm only dividing first term into first term. That's all I care about. So 2x goes into 6x. How many times? Should have had 3 times, so positive 3. And now I multiply it. 3 times 2x is 6x. 3 times a -1 is a -3. Don't forget you're subtracting here. These subtract and become a 0. Negative becomes positive. -3 plus 3 becomes 0. So in this case, I have no remainder, which means that my final answer is just right there. 2x squared plus x plus 3. For example 4, I'm going to go ahead and get you started on it. Then what I want you to do is I want you to hit pause. I want you to try to work it out on your own. Then I want you to go back and hit play and actually check your work and fix it if you need to. Stop and look at any mistakes you made. That'll give you a chance to practice this once before we try it in class together. So example 4 asks to divide -3x plus 4 plus 9x squared by 1 plus 3x. So, hopefully some of you noticed a little bit of a problem just in the way these are set up. They're not in standard form. So first thing you would want to do is rewrite them in standard form. So I'm going to rewrite the first polynomial in standard form. And when I do that, I get 9x squared subtracting 3x plus 4 by, and same thing here, standard form, 3x plus 1. make sure negatives stay with the correct terms in those. This had been minus 3x and negative would need to be there. So just keep your negatives with the correct terms. Okay, so when you go to write this out, 3x plus 1 divided into 9x squared. I have an x squared and then an x and then just a number. So I didn't have to add any zero coefficients in there. Minus 3x plus 4. Go ahead and hit pause now. Try it on your own and then hit play when you're done. Alright, hopefully you tried it, didn't get stuck at all, and you're ready to check your work. So we're looking at 3x. You're dividing 3x into 9x squared. And when you did that, you should have had 3x. Remember, it goes over the same term there as far as your degree goes. 3x times 3x is 9x squared. 3x times 1 is 3x. Don't forget your subtracting here. This is where the mistakes happen. Some of you might even want to rewrite this just with the opposite signs as you go if you tend to make a lot of mistakes on that. 9x squared minus 9x squared cancels like we want it to. This is a negative 3x minus 3x more. So it's not going to be 0. It's actually negative 6x. If you made a mistake there, then you know that your mistake came from positives or negatives right here with your subtraction. So be really careful. Okay, now bring down your plus 4. Now you're dividing 3x into a negative 6x. You should have had negative 2. Again, notice it's lining up with a like term, and a like term. Now I'm going to distribute negative 2. I get negative 6x, and I get a negative 2. Now I'm subtracting everything. So again, these are actually both going to become positive. So this one is 0, and this one is 6. 3x doesn't go into 6. This is my remainder. And you're just going to write your remainder as a fraction over 3x plus 1. So your final answer here is 3x subtracting 2. It's a positive, so plus 6 over 3x plus 1. And you're done. If you had any trouble with that, go back and try to figure out what you did wrong so that you have a better idea of what you're going to need to ask questions about in class tomorrow. And then you can ask any further questions tomorrow in class.